So today we're going to work on lesson 9-2. So chapter 9, lesson 2 on lines of best fit. And it was lines of best fit. Today's date is 5/24/16. So we're going to do a couple different things with the lines of best fit. We're going to write the equation. Of the line of best fit. In a scatter plot. So this goes together with scatter plots, hence the reason why we did scatter plots yesterday. And then the second thing we're going to work on is making a conjecture or prediction of a future value. So a value that's not given to us in our chart, something that would happen down the line. Marcy, we're taking notes. So those are the two main things we're going to work on today. So let's talk first about, let's give a definition of what is a line of best fit. It's a line drawn on a scatter plot that is very close to most of the data points. So here's the interesting thing about this line. This line may not actually pass through any of the points that we graph. It may pass through only one. It may pass through a whole bunch of them. It just kind of depends on the situation, all right? So sometimes all you're going to be asked to do is to take information from a table, do a scatter plot, and then draw a line through it. And then that might be the extent of it. And then based on that line you draw, predict something that is not from your set of data. So I'm going to give you a chart. We'll do one. And the directions, let's say that we've already created a scatter plot. So what I want to do is draw a line of best fit. Oops, sorry. Then make a conjecture. So a conjecture is a guess, but it's an educated guess. It's not just out in the air. It's based on what you can observe. About the cost of cookies in 2013. So I'm going to just create a chart here with that they've already done the graph for us. So you guys are going to have to try to replicate this. I'm going to use a line break in mine. So we've got labels. This is going to be years since 2000. And this one's going to be average cost in money, in dollars. The years we have, let's do counting by twos, 2, 4, 6, 8, 10, 12, 14. And let's do, I'm going to do a line break. And all my numbers are between 2.5 and 3.3. So I make this 2.5. Let's see, 2.7, 9, 3.1, 3.3. So I'm going to graph some ordered pairs here. In 2000, we have 2.59, so that's close to 2.6. So that would go right here. And in the year after, so 2001, we go to 2.81, so about here. In 2002, it was 2.65. So here's 6.65 would be about here. And then 2003 is 2.67. So close. And then in year 2004 was 2.88. So real close to 2.9. And then in year 5, it went to 270. That's easy. And then in year 6, it went to 285. So here's 280, 285 would be about there. In year 7, it went to 288. So about there. Year 8, it went to 317. So about there. And year 9 went to 324. Okay. So what I want to do is to draw a line. And my line, let's see, to go through that, I want to draw the line so that I have about the same number of points above it as I do below it, and that each of those points are about the same distance from the line. Now I do have an anchor spot. I do have where it started on the y-axis. So that's what my line would look like. Okay, now, what's interesting when we do this homework is that your answers may not be the same as your neighbors. So how you can test is based on the answer the book has. Put in the book's answer, and then on Desmos, with the book's answer, put in your answer and see how close your line is. Okay, and so we'll talk about that. I won't be here tomorrow. I have a meeting to go to, so we'll continue talking about this on Thursday and Friday. Okay, now that's our line of best fit. Now they didn't ask us for an equation because now we're just going to make a conjecture about 2013. So here's where 2013 is. So if I take my line and I just extend it, I get an intersection of right about there. So I would say in 2013, let's see, the cost, sorry if I could spell, of the cookies would be about $3.30. Okay, so that's how I use this, is I do an estimation. Now some people may have drawn their graph up a little higher and it would have hit a little higher up. So it's really dependent upon how exactly you draw the line. So this one is very kind of open, the number of answers that are right. Okay, because there's slight variations can make a difference. But as long as we're in the ballpark, we're good. Okay. Now, as a business owner, you want to be as exact as possible. So let's talk about how do we go to the next step and how do we figure out the equation of that line of best fit. Everybody good here? I'll pause. So let's talk about the situation where now I'm actually going to come up with the equation of the line. So this one is going to have some directions. We're going to write an equation in slope-intercept form. Of the line of best fit. That is drawn, so they're going to give it to you. And interpret the slope and the y-intercept. So the whole point behind statistics is that ideal of interpretation. What does it mean? Okay, so what we basically have is the number of cellular service subscribers in the U.S. So let's see, I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 1, 2, 3, 4. So you guys need to replicate this, otherwise your notes are meaningless. So this is your x-axis. This is going to be the years since 1999. $75, $200, $225, $250, $275. Oh no, it's 100. Sorry. So we're counting up by 125, or by 25, excuse me. Talia, stop. This one is subscribers in the millions. So in 1 year after, it was a little bit above 100. In 2 years, it was about 125. 3 years, it was under 150. 4 years, it was a little bit above 150. 5 years was a little above 175. 6 years was a little bit above 200. 7 years was just over 225. 8 years was just above 250. Okay. And then what they did is they drew a line that went through this. And it went through most of the points. It didn't go through all of them, but it went through most of them. Okay. So what they want you to do is to come up with 2 points where it passes through. So this point is a good one. And we need it to be through the lines of the graph paper, so we only have integers to deal with. So that's going to be the point 3150. And then another point would be right here, which would be 9 and 250. Or no, is that right? Oh, 9, sorry. Let me take that one back. They actually went further with their line. So they took this one. 9 and 275. So we talked about this before. First thing we're going to need to do is find slope. And we're going to use m equals difference in y's over the difference in x's. So with our data, we have 150 over 3. We have 275 over 9. We're going to connect and subtract. That ends up giving us a negative 125 over a negative 6. And two negatives make a positive, so we get 125 over 6. Now, they gave an approximation of this by rounding it to the nearest tenth, or hundredth actually. So they have 20.83, and you'll see in a minute why they came up with that decimal value. Okay? And you could leave it as 125 over 6 is fine. Okay? And it would work just the same. Now what they said is, if I extended my line this direction, where would it cross the y-axis? Oh, come on. Go away. And so they said, let's use that value. So what would this value be? Okay. So we would say, find the y-intercept. And we would say the b value is approximately about 85. So our last step would be to write in slope-intercept form, write equation in slope-intercept form. And if you don't remember, that's the y equals mx plus b. So all we do is plug the numbers in where they go. So we would say, well, that equation looks like it's y equals either 125 sixths x plus 85, or using that 20.23, you could say y equals 20.83 x plus 85. Okay, so now we have to get to an interpretation of what this means. Okay, so at the y-intercept, so this is the 0.85. So that means that in 85 subscribers, let's see, in 1999, so when it started, there were about 85 million cellular subscribers. So that's the first thing to interpret the y-intercept, to interpret the slope. The slope indicates that about 20.83 million more people had cellular, or subscribed, let's say it that way, subscribed to a cell plan each year. So the slope is telling us what's happening from year to year, and the y-intercept is what we started with in the beginning time. So 1999 is 0 because 1 means 1 year since 1999. So that 1 represents the year 2000. The 2 represents the year 2001. So what if I asked you guys, okay, well, what do you think would be the number of subscribers in the year 2015? So let's think about that. 2015. So I'm going to go to the next. Could you imagine trying to draw out this picture? How many years after 1999 would 2015 be? No, you can calculate it. No, 2015 isn't 5 years after 1999. How many years? How many? 16 years. So I would have to draw this graph 16 years. I'd have to go 6 more than what I have. I'd have to extend my line, and I'd have to try to figure out what number it is. So instead of doing that, I'm going to let the equation help me come up with this answer. Okay? So again, the question is, predict the number, or conjecture, predict the number of subscribers in 2015. So first off, we know that 2015 is equal to 16 years after 1999. Now, let's look back at the graph. What variable does years after 1999 represent? X or Y? Represents the X's. Gray, you need to be listening. So what this tells us here, this is our X value. Then I take the equation that we came up with. Y equals, and let's go with the, we'll go with the 125 over 6. And then it's X, and then we had plus 85. And now what we're going to do is substitute in 16 for the X. So I can simplify, these are both even, so divide out at 2, and then I can multiply with my calculator. Hold on. And I get 125 times 8 is 1,000, and 1,000 divided by 3 is going to give me something like 333.33, and I'm going to add 85 to that. Zach G, I don't see you writing. So we would get the answer is about 418.33. So we would be able to conclude that in 2015, there will be about 418.33 million cellular subscribers. So again, coming up with that equation is going to make predicting future things much easier than having to expand out our graph and try to figure out where that lands. So that's the point why we come up with that equation. Now I'm going to attach a video. So actually I think this is what we've noticed that the book does is when you are asked to draw your own line of best fit, is kind of figure out where the y-intercept would be and use that as a starting point. And then draw the line so that it goes through the center of the majority of the points. Have the same number of points above as below, and make the distance those points are from that line as close to each other. When I'm picking points to use to figure out slope, now all I'm looking for are intersections of the lines of the graph paper. Okay, so this is a fudgy thing, right? There's no exact. And I've had student after student, when I've asked, well, what was your equation? What was your equation? What was your equation? And they all had different equations. But when we used Desmos and we plugged in what your equations were, they were all very similar to what the book has as an answer. So if you get the book's answer, my thought is you probably just copied it out of the back of the book, because it's really hard to get that exact answer, okay? So you're going to use your book if there's graphs in it. Or no, we're doing not book work, we're doing a worksheet. And it does have graphs on it. If you feel like you need graph paper and need more space to do things, then feel free to take graph paper as well, okay?